So in this section, we're going to talk about virtual networking in some more detail. Now, as we saw in the last section, virtual networking is sort of the backbone that allows resources to talk to each other in different regions or in the same region. And there's various technologies Microsoft is offering to allow us to do that. Let's start by creating a virtual network. If we go into the virtual network search box here within the Create New Resource, we can see that we're given the option of creating a virtual network. A reminder that we want to create Resource Manager resources only. I'm going to click Create. Now, just like most things, we have to give it a name. So we're going to call this New Net. The first big decision we have to make is this concept of an address space. Now, Microsoft allows us to define, because this is a private address space, we can use basically any IP address range that we want. The Internet authorities have reserved the 10 .IP addresses for private use, so you will not find a public IP address that starts with a 10 . There are some other ranges like 192, 168, etc. But the 10 is the entire A block that's reserved for private usage. But this doesn't stop us. If we wanted to make this 190.0.0.0, we could do it because that's a private IP address, and there's no way any computer in the world will be able to connect to this virtual network because this is a private network. So I'm going to actually go ahead and do that. I'm feeling a bit emboldened by this. Go into my subscription. I'm going to create a new resource group for this. So let's call this AZ new RG 200. Right? Hopefully I haven't used that before. Put that network into a location. Let's instead of West US, let's put this in Canada East. Each virtual network has to have one subnet minimum. Now a subnet, as the name sort of implies, is a part of the virtual network. Okay, so by default it's given the name default, but we can call that whatever we want. Call that front end in this case. Now the subnet is going to be again a part of the overall address space. So I could choose the entire address space, and if I did that, it would be no more room for any other subnets, which is fine strategy if you know for sure that you're not going to need to add any more subnets to this network. The reason why you would want to add subnets is if you need to subdivide your network into tiers like front end, middle tier, back end, and you want to have firewalls protecting the tiers, so you can create an entire network that has pieces to it, and you can create different servers in each one and protect them through using network security groups and firewalls. So let's say we want to create a subnet, but we don't want to use the entire address range. This address naming scheme is called CIDR, and it's an alternative to what used to be like an A block, a B block, a C block, etc. The way that you can remember this is that the /8 block is basically the equivalent of what used to be called an A block. You can see Microsoft is actually listing out the range. So this would be 190.0.0.0 to 190.255.255.255, and they're letting us know that there are 16 million IP addresses in this range. So /8 is clearly a huge number, and hopefully we'll never reach as many resources that we possibly could. If I made this the /16, then the tip here reduces from 190.0.0.0 to 190.0.255.255, and now it's only 65,000 IP addresses. That's still quite a lot. So every time you add 8 to your slash, you actually go down to, now this is a C block. Okay, so basically we have this C block, which is the /16, and then we can basically say /24, which gets us down to only 256 addresses. If we did it like this, we would have room in this network for many, many other subnets. Okay, we can just go 190.1, 190.2, 190.3. That's fine with me. We can actually, if we reduce this by 1, it doubles the number of IP addresses, right? So now denial of service protection, basic is included for free. And basic denial of service protection is basically going to make it hard for people to send traffic to this in a malicious manner. If you upgrade to the standard plan, that's a paid service, and then it does more adaptive tuning. It lets you know attack notification. If you're expecting denial of service attacks, or this virtual network will be exposed to the internet in some way, you may want to consider standard DDoS protection. Otherwise, you go with what Microsoft considers basic. Service endpoints. Now, this is a pretty cool security feature. We can basically open up this virtual network to connect with some of the built-in Azure services exclusively. So I could say this network connects to Microsoft SQL database, Service Bus, Key Vault, Cosmos DB, etc. And it basically is a secure channel between this network and that service that the traffic would not travel over the open internet. Without it, then the traffic that goes from these addresses into resources on this network will travel potentially over an open network. Also, we get this choice of opening up a firewall onto this network, and Microsoft will actually allow us to create a brand new subnet for this firewall, and it's basically going to choose the standard SKU, and there are going to be costs associated with this. So we're not going to do firewalls for now. So you can see it's very simple to create your first virtual network. There's no cost to it either if you didn't choose standard protection or enable a firewall. So I'm just going to click create. And as you can see, that only took 23 seconds for that to do that. Now, if we go inside of the resource, we get lots more options in terms of setting up our virtual network. Now, by default, we don't have any devices connected to it, of course. Go into the subnet section. We can see the front end subnet we created using /23 address range, which is 512 possible addresses from 190.0.0.0 to 190.0.1.255, right? So that's 255 address blocks. But you can see that instead of saying 512 available, there's only 507. There are 5 reserved IP addresses in every subnet. And so whatever the total number of IP addresses that you reserved, 5 of them are going to be taken away. This is important when you're using some of the smaller address ranges. So if you're reserving yourself only 8 IP addresses, 5 of them would be taken away and you would only have 3. So keep that in mind when you're doing the math on that. It's very easy to create ourselves another subnet. I'm going to click plus and I'm going to call this one back end. Now remember, we created the 190.0.0.0 range for ourselves, and we reserved 0 and 1 for our front end. So if I was to then make that also a 23, we would go 2 and 3 for this backend subnet. Remember, 5 are reserved. Now we can see some more options in terms of choosing a network security group, which we'll talk about in a second, or defining a route table. Again, we have the same question in terms of service endpoints if we want to enable that, or this subnet delegation, which we could do as well, but we're all going to leave that to the defaults and click OK. Again, it should only take seconds, and at the time that I spoke it, it says it's created, and there we go. Now we have 2 separate subnets on the same virtual network that we can add resources into. And again, we can start to set different firewall settings, different security on these things. Okay. We'll come back in the next lesson and we'll continue with this. Now, we started off this section talking about these IP addresses being private. These IP addresses are not accessible from the public internet. But how would you go about creating public IP address? What we're going to do is we're going to go into this plus sign here for new, and we're going to say public IP. Okay, we'll search for that. And right off the bat, we've got this concept of public IP address offered by Microsoft. So let's choose that. I'm going to say create. So we can now choose to create a public IP address. I'm going to call this AZSJD new public IP 3. Now, we do have options in terms of SKU and in terms of pricing. Okay, public IP SKU must match the SKU of the load balancer. So if you're using a standard load balancer, you get a standard public IP, and a basic load balancer gets a basic. Microsoft does support IPv6 at the load balancer level. The virtual machines and other resources do not support IPv4, but if you IPv6. But if you do need to use that, then you're going to have to put a load balancer in front in order for IPv6 to travel into a virtual machine, because that will convert that to an IPv4 communication. We get the choices between a dynamic IP address and a static IP address. Now, a static IP address is an IP address that never changes, and this is good for when you want to use that IP address in some kind of setting, like a firewall that needs to be opened up, or a DNS registration when you are creating a custom domain name and you need that IP address to live within the DNS system. So you only really need a static IP address if you need to then register that somewhere. The regular domain name system will take care of a dynamic IP address. Basically, what we're going to do is give this IP address a name, and then we can use that name everywhere that we need to. We can choose a connection opening timeout. So basically 4 minutes is the default, so that clients do not need to use keep alive messages in order to keep the communication open. This is where you give it a fully qualified name. Since we're creating this public IP address in Central US region, then the fully qualified domain name is something.centralus.cloudapp.azure.com, and so I'm going to say my new public IP. Probably a terrible domain name, but this is the one that you're going to get for free. Again, you can map this to a custom domain name if you need to, using your domain name register. A CNAME record would be able to map your custom domain into something like this, or you can use Azure's DNS system, which we'll talk about in a bit as well. Now we're going to get an IPv4 for free, but do we want an IPv6 version? We can go ahead and create that if we wanted it. I'm going to go in my subscription. I'm going to put this into my new resource group 200. And I've been putting this stuff into Canada, so I'm going to move this to Canada East as well. And I'm going to say create. So that's going to go off and get me a public IP address in Canada East region. So we've been looking at networking, virtual networks, and subnets. The next topic we want to talk about is called routes, or specifically a route table. I'm going to close this up, go into the create new resource, and we're going to look for a route table. Now, a route table is basically a list of IP address ranges, and that will tell Microsoft Azure how to send traffic that's basically coming over your network. So we're going to create this now, and we'll just sort of look at it very quickly. AZSJD new route. Put this in my new resource group, Canada East, and we're going to just leave the default settings and let that go. So that was fairly quick. Our route table took 25 seconds to create. I'm going to go into it. Now, if we start looking at the routes, we got no custom user-defined routes by default. So let's add a route to this route table as an example. Now let's say we want to implement a rule that says any traffic that originates from a server running on the back-end network that we created for that other virtual network, we want that to go through a firewall before it leaves the network. So I'm going to say send to firewall as being the rule name. We want, let's say we set the backend network, so that's 190.0.2.0/23 by memory. And we want this traffic to be sent to a virtual appliance, and that virtual appliance is going to end up being a firewall. Now, we have not created this virtual appliance yet, and might be outside of the scope of this lesson to do so, but let's just assume that our firewall is sitting there waiting for someone to talk to it at 190.0.4.1. Again, we haven't yet created it yet, but this is where traffic originating from these sources are going to be sent. So now we're going to create that rule. Now we haven't even associated this route table with our subnet yet. So let's go down to the subnet section and say associate. We have to choose the virtual network, which is our new net, and we wanted this rule to be associated with the backend subnet. So traffic that travels over the backend subnet has to follow this route table. So within the last year, Microsoft came out with a relatively new feature called Application Security Groups. Now, Application Security Groups are an enhancement to network security groups in that it allows you to reduce the number of network security groups that you require or in the number of security rules that you require. Now, the way it does that is by grouping resources that have the same rules together. So instead of having to create a separate network security group for every subnet that you have and then separate rules for every resource, you can put all of your SQL Server databases, all of your application servers, all of your web servers into the same security group. So let's examine that. I'm going to hit the Add button. I searched Application Security Groups up here, and now I'm hitting Add. We do have to choose a resource group for it. I'm going to put this in the AZ300 resource group. And I'm going to call this My Application Security Group. And I'm going to leave that in WestUS 2. Now, it does take a moment to create. So I'm going to click Review, and I'm going to click Create, and then we're going to pause the video and come back once this is created. All right, so that completed. We're going to say go to Resource. Now inside the application security group that we just created, there's absolutely nothing here. It's a completely blank overview screen and there's really no settings to speak of. So what's going on? Well, in order to see what's going on, we need to assign this application security group to a resource. Now, the application security groups are limited to the region in which they have been created. So we created this in WestUS 2. And so let's going to go to the virtual machines tab here. Now, I do happen to have a virtual machine running in WestUS 2. So I'm going to go into that. And we can see this machine was just started, actually. If I go down to the networking section, we can see that the virtual machine has NSG rules, inbound port rules, outbound port rules, and there's this tab called Application Security Groups. So when I click it, I can see there's no application security groups associated with this network interface, and I can say configure the application security groups. Now it does say showing only security groups in the same region as this. So I can put this into the My ASG security group. Let's do that. Now what we can do once this updates is we can modify the network security group. So we're going to go back to the network security group and we can say we want HTTP traffic traveling inbound. So any source, any port, but we can actually point that, instead of pointing to the IP address of the VM, or instead of allowing it to any destination, we can actually specify the My ASG application security group as being the allowed destination. So as you see here, we can be very liberal in terms of allowing traffic to travel to any address, which is a security risk. We can be very specific, which is hard to maintain. Or we can create this abstraction application security group, which allows traffic to travel to any VM that's listed in this ASG group. And let's say we want port 80, allow priority port 80. So now this new rule is going to allow traffic to any VM that's part of this group. And I don't have to modify the network security group for it. And I don't have to allow all traffic to all VMs.